in this question, we need to figure out the upward force on the foot wedge from the support X, right? So this is the support X, and we need to calculate the upward force, which is acting at the support X. Let's mark it as Fx. And the key points we need to consider over here is we are considering support Y as our pivot, all right? So support Y is our pivot, and we are going to check the moments and the torque or the moments across this pivot, which is support Y. So first of all, let's mark all the forces. So since this beam has, sorry, I'm saying a beam, not a beam, a beam. This beam has 4,000 Newton of weight, and this will be acting directly from the center of this beam. Why? Because at the center, because this is a regular beam, and we can say that the center of mass will be exactly at the center. So this is the center of mass, and from here, the weight of 4,000 Newton will act, or supposedly will act. Now we have the force Fx, and the weight of this man is acting directly from here, which is 600 Newton. We know that the man weighs 600 Newton. Right now we have mentioned all the forces and their directions and the distance from the pivot. Oh, sorry, let's mark the distance from the pivot as well. So this distance will be, because this is exactly at the center of the beam, so this will be the whole length of the beam is 12, so this will be 6 meters, right? The distance from the pivot for the man is, so overall length is 12 minus 4 is 8 meters, right? So this distance will be 8 meters from the pivot, the man is standing at 8 meters from the pivot. And lastly, the force Fx is acting upwards at the distance of 12. We know that this is 12, right? So now these two forces, the weight of the man and the weight of the beam, are actually causing the clockwise moment. All right, so these are causing the clockwise moment. However, this force Fx is causing the anti-clockwise moment. Anti-clockwise moment. And the trick here is, since this beam is in equilibrium, we know that the clockwise moment is equals to anti-clockwise moment. Clockwise moment is equals to anti-clockwise moment. Why? Because currently the beam isn't stationary and the beam is in equilibrium position, right? Now we can equate this using some mathematics. We can say that the clockwise moment is caused by 600 Newton. So 600 times, how much is the distance from the pivot? 8 meters. So 600 times 8. Make sure the distance in meters, plus another force which is causing clockwise moment is 4,000 Newton. So 4,000 times, what is the distance from the pivot? It is 6, equals to the total anti-clockwise moment actually. So the anti-clockwise moment is caused by the force Fx. So Fx plus, sorry, not Fx. So the moment is force times distance from the pivot. So Fx times 12 meters, right? Fx times 12 meters, yeah. And now we can easily compute the force Fx. What should be the Fx force? The Fx will be equals to, so 600 times 8 is equals to 600 times 8 is 4,800. And so we can say that this is 4,800 plus 4,000 times 6 is 24,000 divided by 12 will give us, so 24,000 plus 4,800 divided by 12 will give us the Fx. So Fx will be 2,400 Newton upwards, okay? Upwards, because it needs to cause the moment should be clockwise actually. Moment should be clockwise. And now we can say that the force will be C.